Hi, this is Vishnuvandana, and we are from Team 18. And our project is the Internet of Things into operating systems, their challenges, proposed framework, and the future directions. And we are here to discuss a study that presents a helpful plan for managing Internet of Things devices, edge computing, resource management, communications, security, and privacy. Our project also explains why operating systems are super important for successful IoT devices. We also looked at previous research to find the best ideas and methods for each topic, including the challenges that our people faced and recent successes. The proposed plan will give a clear structure and important paths to solve those problems. We also talk about the good points of this plan and why it is useful. And at the end, we shared the study's main results and suggestions for future research. Coming to the introduction, the Internet of Things has been a very significant event in digital computing's development. It's been about connecting everyday devices to the internet so that they can share data and work together. The idea of Internet of Things has started in 1980s. As you can see here, it's a diagram and here are the years and how the IoT developments have been made here. So the idea basically started in 1980s, but the term Internet of Things was coined in 1999 by Kevin Ashton. And the IoT has grown a lot and is changing how we use technology in our daily lives. It can also improve industries, make things more efficient, and create new services and applications. But bringing all these technologies together is challenging. The operating systems are really important for managing the IoT systems. They help to control IoT devices like setting them up and updating their software. Operating systems also make sure the devices can work together well and use resources efficiently. Edge computing is another cool thing they do. It means processing data closer to devices, which makes things faster and uses less network power. The operating system also takes care of all this data processing. They also handle how resources like memory and power are used in IT systems. And to make devices communicate safely, operating systems use special protocols and networking tools. It's basically like they are the brains behind the scenes, making everything in the IoT world so smoothly. And here we have discussed all of the IoT topics. That is, we have basically the five topics like IoT device management and OS, edge computing and OS, IoT resource management, communication in IoT, and IoT security and privacy. So, coming to the first thing, IoT device management and operating systems, this is basically like how they connect and communicate on the internet. We look at the protocols and frameworks used for managing these devices, explaining their features and limitations. We basically focus here on the important aspects like setting up devices, adjusting their settings, monitoring them, and controlling their actions. This article will help the researchers and the practitioners in the future to choose the right protocols and the frameworks for their IoT projects. We also talk about two types of managed devices, ones with lots of resources and ones with limited resources. Finally, we suggest the future research directions like edge computing and machine learning to improve IoT management even more. And coming to the second topic, edge computing. Edge and fog computing are becoming more popular because they have many advantages over standard cloud computing. Edge computing brings data and services closer to the users, making the things faster and more efficient. It basically uses devices like small IoT platforms or powerful servers to handle processing and storage locally. Both cloud and edge or fog basically serve similar purposes, but their implementations can vary depending on the applications and devices. And coming to the last thing, the security is very essential, especially when dealing with the edge or fog, and researchers are examining the risks associated with virtualization. Coming to the third topic, IT resource management, the Internet of Things is growing rapidly and has been becoming a big part of our lives today. New technologies are driving this progress, and we need affordable hardware and better communication methods for IoT to continue evolving. To make things work smoothly, we need standardized rules for developing IoT devices and their operating systems. The systems here must adapt to changes in the network intelligently. And the researchers have also been analyzing IoT operating systems to understand the challenges and also find the solutions. And here we are looking at how these systems manage resources like energy, memory, and communication to make IoT devices more efficient and reliable. Coming to the fourth topic, that is communication in IoT and operating systems, the Internet of Things is a crucial part of today's research and technology, and it has been so responsible for creating new applications in different areas like medicine, education, smart cities, and agriculture. And in this article, we have explored the whole scope of IoT and how it impacts our lives. Smart sensors are basically a key part of IoT as they are used to connect to wireless and the internet to make automatic applications work with human involvement. And IoT also relies on technologies like the big data, AI, and machine learning to handle large amounts of data and devices. And the challenges like connection, coverage, security, and scalability are still being worked on. And let's come to the fifth topic, that is IoT security and privacy. So, in here, we are basically going to talk about the security and privacy challenges in IoT, which means that connecting everyday devices to the internet. We also discuss how IoT devices and networks can be vulnerable to threats like unauthorized access, data breaches, and privacy violations. And we have looked at the existing research and also suggested the solutions to deal with these issues. We also mentioned a technology called containers that can help handle many linked objects effectively. But if these containers share the same operating system, it can cause security problems like data leaks and service takeover. So the industry basically needs to work on fixing these flaws so that it is safe and secure to use these IoT applications. And the methodology and the challenges will be explained by my other teammates.
Thank you, Vandana. Thank you so much. Well, so far we've seen what are the maybe flaws which we can within the IoT and OS system, and we are going to see how we are going to overcome these flaws and how we are going to implement all of these things in the future preferences. So as we can see, and as we can go through a thorough literature review in the previous section, and doing a well research in the IoT frameworks and operating systems, we have come up with a conceptual framework was developed through group brainstorming and debate. The findings are very literal, but it's going to impact much more rather than in the large scope of the IoT systems. As you can see, the group has considered an independence between the Internet of Things and operating system, while designing its proposed framework. A high-level architecture has been proposed in the upcoming areas. So the effectiveness of this, Vandana, I want you to go to the previous slide. Yeah, thank you. So the effectiveness of the suggested framework is resolving around the problems which were discussed in the earlier section and filling the voids that were mentioned in the paper. So the degree to which the framework met the needs and objectives was discussed in depth. So let's, Vandana, can you just go to the other slide? Yeah. So here are a few significant challenges that we have come up with during this technology that has been rapidly developed throughout the years. There are some of these challenges which was mentioned here. So let's go with one by one. So if we consider as the independencies between IoT systems and operating systems, so the one of the common theme that emerges from these IoT systems that is independence between the IoT and operating system, which is more like the a suitable IoT system for this particular operating system. For example, there will be a lot of operating systems. There are a number of IoT devices, but A few devices will only support at a particular operating system. For example, if we take a Linux operating system, Linux operating system only consider a, a number of IoT device which can only support it in that particular system. So it will not be supported for the Windows system. So the evolution between the Linux and the Windows has been grown rapidly throughout the years, but the supportive systems have not yet managed. So let's go with the constraints and the management. So it's a significant challenge across all topics, but managing the resources and execute the resource intensive voice functions are a vital role in this performance. So we take it when it comes to resource constraint and management. So it will also comes under process management and memory management and communication management. So the next topic will be a security and privacy concern. So when it comes to a IoT device, a security plays a major role because at the end of the day, the IoT systems will interact with the humans. The IoT ecosystem has a significant difficulties with security and privacy. Well, when it comes to accessing the human resources, the diverse and massive nature of IoT devices, and they produce the secure authentications and encryption methods. Privacy protecting technologies may include IoT operating systems and communication architectures as always needed in these present generations. Standardization and interoperability. The management devices, resources, communication protocols are efficient role where the IoT systems are gonna perform in the wide range of cloud-based systems. So due to the wide variety of devices, protocols, and operating systems and frameworks that are required to ensure a smooth and integration process and communication process interface for managing devices. So far we've seen all the a number of challenges which we can accomplish by using IoT. Let's go with the proposed framework and proposed solution. So the framework solution that which we have come up with in this paper is a cloud-based self-adaptive middleware platform for IoT collaboration service. So the reason why we chose this particular framework is which is very flexible, and the resource constraints will be a very feasible to each and every system and the person whoever using this platform. Vandana, can you just go to the next slide? So as you can see this picture over here, so there are a number of users that is representing with the violet boxes. As you can see, non-adaptive systems and self-adaptive systems and passive sensors and accurate devices, publish subscribe communication layers. So when it comes to taking non-adaptive systems, PCs and tablets and many more, like be it as the operating system, let's say a tablet, let's say a mobile phone, let's say a computer and whatnot, even everything which we can be accessed through human body is every other thing is IoT system. So the non-adaptive system stands for a conventional computer equipment that is are part of IoT's network. The computer power and other features of these platforms are useful to this group effort. So the self-adaptive systems is nothing but act as their own. Let's, for example, a AI or a human being, such as, like I said earlier, so such as robots and unmanned aerial vehicles are represented by this system. To reach their collaborative goals, the system can dynamically adjust their behavior and characteristics. So the passive sensors and author actuators is nothing but as we can see in our daily lives. So we have our smart security home systems where if any theft will be happening in the room, the security systems will be alerted, and a direct notification will be sent to the owner. So it's nothing but a sensor operating system. And the publish subscribe communication layer is nothing but an approach to create a scalable and efficient communication between the platform and the IoT devices. A like I said earlier, this is the block diagram that we have come up with to illustrate the communication between the end user to the cloud-based IoT systems in this application. Vandana, can you go to the next slide? So here is the proposed framework, as you can see. So there is a third person on the left side who is using the lab, who is using the system. So he cannot directly access to the IoT cloud-based systems. So first he has to go to the server side where the IoT servers will be launched through server, and this request has go to the in cloud where it will start a virtual machine IoT collaboration service. According to the user request, the virtual machine will run through some operations like memory and analyzing and processing and expansioning. By using a small amount of resources which was mentioned at the below, which are nothing but sensors, actuators, and non-adaptive systems and self-adaptive systems, and gives us the a resultant produced work as a cloud at the human interaction section. So before I going to pass on to my one of my colleagues, I would like to say that today's the IoT systems has become a vital role throughout any human being life. Like without IoT, there is nothing going on at this time around. Be it as a technology and be it as a evolution between the human beings, and even the AI. The AI requires Internet of Things right now, and I would like to talk about more. I would like my another colleague talk about more about this in the discussion section, as we mentioned all other things in this. So, Mr. Rakesh, go ahead and give your perspective of this paper.
Thank you, Shiva. In order to overcome these difficulties and boost the IoT performance and the security, the best solution is the cloud-based self-adaptive middleware platform for the collaboration services in the IoT. However, the framework uses a cloud-based platform to promote the harmonious cooperation between the IoT devices and the different platforms. An, effect, an effective OS for the IoT can provide the streamlined control over the networks and infrastructure, the device resources, and the data transmission and the security precautions. Because of the framework inheritance flexibility, the resources can be effectively managed, allowing the IoT devices to effectively carry out the compatible operations and execute the resources intensive OS activities. It dynamically distributes and optimizes the processing the power, memory, and energy depending on the real-time demands. As we discussed with our team members thoroughly, we came up with the proposed cloud-based self-adaptive middleware platform for the IoT collaboration services, addressing the challenges which is mentioned in this paper above. The frameworks are definitely benefited such as enhance the collaboration, resource optimization, secure the communication, and standardize the integration. Make it a promising solution. However, the considering the facts mentioned in this paper, the real-time adaptive warranty, the future more research framework, effectiveness in diverse IoT environment. I would like to pass my point to one of my colleagues.
Um, Thank you, Rakesh. Well, coming to the conclusion, we can conclude that This study article presents a thorough analysis of the relationship between operating systems and the administration of the IoT devices. Well, and this article also mainly highlights the key principles, current techniques, challenges, and the recent advancement in the various areas, just like the IoT computing, IoT resource management, the edge computing, the communication, and the security and privacy. And moreover, this research results have also concluded in the development of a comprehensive framework utilizing the cloud-based self-adaptive middleware to integrate and optimize the IoT device management, edge computing, security, and the privacy. This proposed framework addresses the interdependencies between the IoT and the operating systems, promoting the interoperability and the efficiency while ensuring the safety and privacy. We can also say that in the future research areas, it will also include the edge computing, security solutions, and also the dynamic resource allocation strategies to optimize the IoT system performances. Thank you.
Well, I would like to say something before we end this discussion. On behalf of our team members, we would like to thank you, Professor, for giving us this great opportunity to express ourselves in this particular IoT and OS. And we are looking forward to see you. Thank you, Professor.
Thank
Thank
you.
you, Professor.